Outer space has its own weather. Storms from the sun that can harm satellites, astronauts, and even our own power grids right back here on Earth. And NASA is launching this week 3 new spacecrafts that will map space weather and the sun's influence across our solar system. And here to talk about this exciting new mission is NASA research astrophysicist, Dr. Alex Gloser. Alex, how are you this morning?
I'm doing great. Thanks for having me.
Now, this is fascinating stuff, and one of the spacecrafts that NASA is launching includes the Carruthers Geocorona Observatory, which you work on. Now, before we dive into this mission, can you briefly tell us more about that launch?
Yeah, absolutely. So NASA is launching tomorrow 3 very exciting missions. IMAP, which is going to look at the boundary of the solar system with interstellar space, the space weather follow-on mission, SWIFO L1, which is going to have a space weather focus, and then the Carruthers mission that I'm involved with, which is going to look at the geocorona, the exosphere, the outermost layer of Earth's atmosphere.
Yeah, can you tell us a little bit more about exactly what the Carruthers mission will be measuring and why that's really important for understanding space weather in general?
Yeah, absolutely. So the Carruthers mission is going to be looking at the outermost layer of Earth's atmosphere, known as the exosphere, and it's going to look at it by looking at the scattered light that's coming off of the hydrogen in the exosphere. Basically, ultraviolet light is getting scattered by the particles in the exosphere, creating a glow known as the geocorona. And Carruthers is going to be imaging that glow from the Lagrange point between the sun and the Earth in order to understand how the exosphere is evolving over time and how it's responding to the sun's influence.
Yeah, obviously everything you guys do is super specific and scientific. So this observatory and the other satellites launching on this ride share will be placed in a special orbit 1 million miles from Earth. Why was that location chosen in particular?
Well, that's a great question. So the Lagrange point that you are talking about is the location between the sun and the Earth where the gravity between these 2 celestial bodies is in balance. And for the Carruthers mission in particular, it's an ideal location where you can look at the exosphere continuously to see how it's changing and how it's evolving in time. But in particular, you're far enough back that you can see the entire exosphere. The exosphere is actually quite large, and to fit the entire thing in a shot, you have to back up. Kind of like when you're at a party trying to take a picture and fit all your friends in the picture. If your camera is too close, you can't fit them in. It's the same thing with the exosphere. If you want to see the whole thing, you have to be far enough back in order to see it.
A lot of the other things that NASA seems to do as well is building upon previous missions, and this Carruthers mission continues work from Apollo 16. So can you tell us a little bit more about how those missions connect and how it's working towards what's happening today?
Yeah, so the Carruthers mission is actually named for Dr. George Carruthers, who was an outstanding scientist and engineer, and he's particularly well known for developing a telescope that landed on the moon in 1972 as part of the Apollo 16 mission. And that actually gave us the very first image of the exosphere and showed us just how large it is and that you could actually image it by looking at this geocoronal glow. And so the Carruthers mission now is going to be carrying on that legacy by being the first dedicated exospheric mission that's going to track how the exosphere is changing over time and its importance for space weather.
So next year, NASA will send astronauts around the moon with its Artemis program. Can you tell us why understanding space weather is so critical for human space flight missions?
Yeah, so we're all very excited here at NASA for the mission of exploration, and part of that is to protect the astronauts as they go out and explore. And so, space weather refers to the hazards in space that astronauts might encounter, the radiation hazards and the impact on their communications and other supporting technology. And so just as if you're going out on a fishing trip, you might check the weather forecast to make sure there's no thunderstorms or other hazardous events before you head out on the ocean. Astronauts need to pay attention to the space weather report in order to protect themselves and their technology. And these missions are going to advance the knowledge to do that forecasting.
Yeah, this is fascinating, Dr. Closer. We'd love to catch up with you again some more after there's some more information or if there's more updates. Is that possible in future?
Of course, I'd be very happy to. And, if any of your viewers are interested in learning more, they can go to nasa.gov/sun or follow on social media.
Dr. Alex
NASA
Closer.
Solar System.
Dr. Alex Closer, thank you so much for your time this morning and best of luck with everything.
Thank you. It's been a pleasure.
If you want to learn more about NASA's special missions and their outcome, just head to nasa.org/sun.